Hello everyone, we are going to discuss today a topic which is very important. There is no there is a direct question as well, and sometimes it's application in reaction. So tautomerism, it is a kind of isomerism as well, and we are going to discuss ketoenol form. Ketoenol. In this specific isomerism, keto means aldehyde and ketone both. While it sounds like keto form only, ketone, but it means aldehyde and ketone both. Aldehyde as well as ketone. And we all knew aldehyde means RC double bond OH and ketone is RCOR. Clear? And what is enol? Enol means whenever OH is directly bonded to a double bond carbon, means OH bonded to carbon double bond carbon. Okay, so those compound in which OH is directly bonded to a carbon double bond carbon, that is called enol. For example, like this one or this one. Clear? There are so many examples. So the thing is, whenever OH is bonded to sp2 hybridized carbon, which means double bond, then we can say that is enol form. So now we have a condition for tautomerism. All the aldehyde and ketone cannot show tautomerism. There is a condition behind this. So let me tell you the condition for tautomerism. Only those aldehyde and ketone can show tautomerism if they have at least one alpha H in ketone or aldehyde molecule. So I can write here only those carbonyl, or even we can say aldehyde and ketone which has at least one alpha H must be present. So what is alpha hydrogen? So suppose we have this carbonyl bond. So the neighboring carbon bonded to the carbonyl, that is called alpha carbon. It can be any side, either left or right. And if that carbon have a hydrogen, at least one is good enough. This one is known as alpha hydrogen. Clear? So now I am going to give you some example, and you have to tell me which one is going to show tautomerism. So in the first one, the carbonyl neighboring is alpha carbon and have a hydrogen, so it will show tautomerism. Here as well, this is alpha carbon and having alpha H, so it will show tautomerism. In this case, we don't have any alpha carbon, so there is no tautomerism. So here we can say this is my carbonyl carbon, this is the neighboring carbon alpha carbon, but here we don't have any hydrogen, so this is not going to give tautomerism. This one is carbonyl, this one have alpha carbon, and here we have a hydrogen, so it will form a tautomerism. And this one is alpha carbon, but we don't have any hydrogen, so again it will not. Clear? So now I am going to discuss the conversion of keto to enol and enol to keto as well, because it is reversible. So look at here. Suppose we have the keto form. I am going to tell you the trick only, not the mechanism. This reaction is carried out in both medium, acidic and basic. But here I am going to just tell you the trick behind this. So look at here. This is the keto form, and now we have to draw its enol. So this is my alpha carbon. This is the alpha carbon. We have to shift one of the alpha hydrogen towards oxygen and double bond back to the alpha carbon like this. Suppose this hydrogen with oxygen and double bond to the alpha carbon. So you have CH and H, double bond OH, and this one is also H. Clear? So this one is my keto form and this one is the enol. Clear? We have another one, suppose this one. Now we have to draw its, we both sides have alpha carbon, so you can choose any one because they both are symmetrical one. So as you can see, hydrogen with oxygen, double bond on alpha carbon. So this is my enol. Clear? Keto form is more stable than enol, especially whenever you have just one keto, mono keto. So whenever you have enol, it will shift to keto form because keto is more stable than enol. So I am going to tell you how to convert enol to keto. This one. So you have to do the same thing, double bond back to the oxygen and hydrogen back to the alpha carbon. Okay. So double bond here and hydrogen to the alpha carbon. So it will be CH3, C double bond OH. Clear? Same here. This one is my alpha carbon. So hydrogen back to the alpha carbon, double bond on oxygen. So we have a ketone molecule. Makes sense? So now we are going to apply tautomerism in a reaction. Suppose we have an alkyne and we are going to react with HgSO4 with H2SO4. So this is a hydration of alkyne, and we all knew it forms alcohol first with Markovnikov. It means it is an addition of water. Okay, it is an addition of water. So with Markovnikov's addition, so OH is going to attack on this carbon and hydrogen on here. So we have this enol first, CH3, COH, double bond CH2. So this is enol. We all knew this is unstable here, so it is going to convert into tautomerism, means keto form. So we can say this is hydrogen back to the alpha carbon, double bond with oxygen. So we have CH3, C double bond O, CH3. Clear? And this is the final product. Keto and enol are isomer of each other, and you can compare the molecular formula. So here we have C3, how much hydrogen? 6 and oxygen. Same here, C3, H6, oxygen. And it is a kind of constitutional or structural isomer because we have a different structure. It's not stereoisomer, okay? So they both are constitutional or structural isomer, and in constitutional or structural, it is a part of tautomerism, and tautomerism is a special kind of functional isomer as well. Why? Because we have a difference in a functional group. Here we have a ketone, here we have alcohol or enol, you can say. So these two have a different functional group. So we can say this one is a kind of functional isomer at the same time. Thank you so much.